Hey everybody, welcome to Earth, Moon, and Sun study session. Let's see if this works. Earth, Moon, and Sun study session. A couple of things that we're going to go through, we're going to talk about today is, the first is the movements or motions in space. So there's two big motions that people get confused a lot of times. The first one is rotation. And rotation is an object spinning on its axis. That means here's the axis of Earth, and the axis says it's an imaginary line that an object spins around. So if you picture, if you are a skateboarder or a snowboarder or a figure skater, if you are here and you've got a trick or something that you're doing, you're going to spin around in a circle. That's rotation. And if you go all the way around once, that's 360 degrees. Alright, so if you spin, standing up, like if you jump up and down and spin, you'd be straight up and down, right? Well, the Earth is actually tilted at 23.4, or a lot of times we see 23.5 degrees, like that. And we'll talk about that later, but that's very important. Why that's tilted, or it's important that that is tilted. The next motion is revolution. So the key word there is revolve. And I think about a revolving door. You go around and around and around. You can keep going around and around in a revolving door. But what we do as the Earth right here, we revolve around the sun. Alright, so the revolution is the actual movement. So this letter C would be revolution. I'll just put revolve. Okay. A would be rotation, because it's just spinning around its axis. And B, the path that something takes, is called an orbit. So that's the actual imaginary line in space that the Earth goes around. Or the moon also has an orbit around Earth too. It goes around and around Earth at the same time. So to review, revolution is the movement and the orbit is the path. Alright, the next thing we have to figure out is what we call a day and what we call a year. So a day is the time it takes for the Earth to rotate once. So that's one spin around, one spin. One spin of the Earth, and that is a day that takes 24 hours. And this is why the sun will rise and it'll set in one day, because we are spinning. The sun isn't moving at all. We are just seeing it look like it rises and sets in the sky because we're spinning. And then a year is the time it takes to go all the way around the Earth, going all the way around the sun. That takes 365.25 days. And that's important, that 0.25, because that is what we call leap year. Why we have to have a leap year is because it actually takes just a little bit more, 1/4 of a day longer than 365 days to go all the way around once. So every 4 years, that adds up, 0.25 to 0.5 and 0.75, and then after 4 years you have one full extra day. That's why we have February 29th, which is called Leap Day. And so that keeps the calendar on schedule. And then why do we have seasons? It's all about this tilt. So if you see that, you should always think of the tilted axis. It's also because we have an elliptical orbit, but the big thing is the tilted axis. Some people will have the misconception that we are closer to the sun in the summer. Well, we are actually closer to the sun in December. So that doesn't make any sense, right? You would think that if you're closer to the sun, you'd be warmer. Well, it all has to do with sunlight, and it has to do with how direct the sunlight is. So we've got a couple terms here. We've got equinox, and that means that there's equal parts day and night. So if you look, this actually stands for equal, and then nox means night. So you've got equal night. And that happens 2 times. In the fall, that happens when the days are getting shorter and shorter. And then in the spring, the days are getting longer and longer, and you get to 12 hours of daytime, 12 hours of nighttime. That's called an equinox. This is also the first day of fall and the first day of spring. All right, the next term is solstice, and solstice is the opposite. Solstice is when we are completely tilted towards the sun or completely tilted away from the sun. And the summer solstice is the longest day of the year. The winter solstice is the shortest day of the year. So if this is my sun here, the earth in the summer solstice, the northern hemisphere is tilted towards the sun, and in the winter it's tilted away from the sun, like that. And then the way to remember this is they're all of the solstices and equinoxes are on the 21st or around the 21st, and they're spread out by 3 months each. So in spring, you've got the first day of spring, that's March 21st. Then the days are getting longer and longer and longer until we get to the longest day, which is the first day of summer, that's June 21st. Then after that longest day, then the days start getting shorter and shorter and shorter until we get to September 21st, which is the autumnal equinox or the fall equinox. And that's where there's 12 hours of day, 12 hours of night. The days continue to get smaller until we get all the way down to December 21st, which is the shortest day. And then after that, the days get longer and longer until we get back to March 21st again. So it's just a constant cycle. In between each one of these is 3 months. So those are our seasons. Our 4 seasons are 3 months long each. It's kind of nice that way. And the last thing, this just sums up everything kind of in one little diagram here. You can see that in the summer, in June 21st, we've got our axis here is tilted towards the sun. And as we move around, now it's still tilted, but it's tilted parallel to the sun. So neither the northern hemisphere nor the southern hemisphere are tilted towards the earth, or towards the sun, I mean. They get equal light. And then we get shorter and shorter days. This in the northern hemisphere tilted away. You see that actually some way up here in the very, very top don't actually receive any sunlight during that day, which is kind of crazy. And then over to this side, the same thing. Now we're at another equinox and back to the summer solstice. If you have any questions, that's pretty much all we have covered so far in astronomy. If you have any questions, please talk to your teacher, Miss Bradcliffe, Miss Hill, or me, Mr. Olafson. You can email us or talk to us in class. Otherwise, have a great day and good luck on the test. Bye.